Hey everyone, welcome to This Explainer. Man, I am absolutely pumped to be your guide today because we're going to explore a totally backward, completely thrilling approach to learning. Have you ever heard of vibe coding? Well, today we are literally tossing the traditional rulebook out the window. We're diving into this brilliant concept from Play-First programming that shows you how to master complex visual coding just by messing around and experimenting. So let's jump right in and see how a completely basic text file can turn into a massive interactive universe. You know how learning to code usually goes, right? Well, frankly, it's pretty dry. You sit there, you memorize endless syntax, you stare at flashcards, and you have to learn all these rigid rules before you're ever allowed to make anything remotely fun. But what if you learned by breaking things on purpose? What if we just skipped all that boring foundational stuff and jumped straight into pure chaotic play? That's the exact philosophy we're unpacking today, and it is a total game changer for how your brain absorbs technical stuff. Here's the core idea. We don't start with the rules. We start with a toy. The source material outlines this awesome project called Drifting Stars. The vision here is to build this mesmerizing cosmic window right inside your web browser. Imagine a sleek, midnight black canvas packed with tiny neon stars just drifting across your screen, pulsing with this soft light. But here's the catch. You aren't just building this to sit back and look at it. You're building this engine so you can literally stick your hands inside and tear it apart to see how it ticks. So, how do we start? Well, we outsource the heavy lifting. You're going to open up your favorite AI assistant, could be Claude, ChatGPT, DeepSeek, whatever you like, and you feed it this exact prompt. Tell it to write a single, complete HTML file for an interactive drifting stars simulation. You specifically want a clean, dark container using the hex code 0A1A0F for that perfect midnight black. Ask it to render about 50 smoothly drifting stars with X and Y positions, a speed value, and a neon color pulse. Oh, and make sure you tell the AI to wrap those stars around the screen when they drift off the edge, and, this is crucial, keep all the HTML, CSS, and JavaScript tucked neatly inside one single file. Ask for short comments too, just so you know where the speed, count, and color variables are hiding. Boom, stage is set. Okay, so the AI spits out this big block of code. The tactile setup here is seriously so fast. First, just copy the code. Second, open up a super basic text editor. Notepad if you're on Windows, TextEdit on a Mac, and paste the whole thing right in. Third, hit Save As and name it stars.html. Don't save it as a .txt file. Click tip, if you're on Windows, just make sure to select all files from the drop-down menu first. Finally, step 4, find that file on your desktop and just double-click it. And wow! The second you double-click, your browser fires up and neon stars are suddenly drifting across a midnight canvas right in front of you. Just take a breath and watch it for a sec. You are officially vibe coding. Think about what you just did. You commanded an AI to build a custom rendering canvas from absolute scratch, and your computer is actively processing that logic right now. You literally skipped weeks of boring tutorials and went straight to a working, interactive product. But we aren't here just to admire it. It's time to turn this into true play-first programming. All right, here we go, twisting the knobs, unleashing the chaos. Let's get into it. To really dive in, you're going to keep your browser open on one side of your screen and your notepad with the code open on the exact opposite side. We are going to tweak one single thing at a time, save it, and watch how the browser reacts. Our very first knob, the star count. Look into that code your AI generated and find the variable for star count. It probably equals 50. That's what's keeping things so calm and peaceful. Well, let's delete that 50 and punch in 2000. Hit save, jump over to your browser, and hit refresh. Instantly, your calm little night sky becomes a raging hyperdrive simulation. I mean, just look at that number, 2000. The wildest part here isn't even the visual star storm happening on your screen. It's realizing the sheer power of your machine. Your browser didn't even crash. It effortlessly mapped 2,000 unique moving vectors all at the exact same time, just because you told it to. You're directly commanding the machine's processing power and getting totally instant visual feedback. Okay, let's twist this second knob. We are going to completely shatter the speed limit. If you look at the math driving the movement, the AI probably set those speed values pretty low, maybe math.random times 0.5 or something. Find those speed values and just crank them up. Change that 0.5 to a 25. Save the file, refresh the browser. Whoa! Suddenly those stars aren't drifting anymore. You've got vibrating, teleporting fireflies tearing across the screen at warp speed. You literally just broke the physics of your own little universe. Ready for the third knob, the cosmic palette. Somewhere up near the top, probably in the style tags or the drawing loop, the AI set the background color to that midnight dark hex code we specifically asked for, hashtag 0A1A09. Go ahead and delete that hex code entirely. Swap it out for a simple CSS color word. Try hot pink, or purple, or dark blue. Save it, refresh. The visual shock is just incredible. Your entire universe changed color with one tiny edit. The stars are still flying around, but the fundamental reality they live in just completely shifted. Okay, let's slow down for just a second and look at what actually just happened. 3 big ideas, 0 flashcards. While you were busy causing absolute chaos on your screen, making hot pink hyperdrives, your brain was quietly absorbing 3 massively important foundations of visual programming. You didn't crack open a textbook for these. You experienced them firsthand. Let's break down exactly what you just learned. So the first major concept is the canvas DOM. When you were staring at that black box, or, hot pink box, you were actually looking at the canvas element. Basically, the browser carves out the specific rectangular grid so a pixel-by-pixel rendering engine can map out visual coordinates. Every single drifting star you saw was actively being drawn right there, frame by frame. The canvas is not a static picture. It's a live, active drawing board. The second concept you picked up is coordinate space. Remember when you cranked that speed from 0.5 to 25? You were literally manipulating mathematical vectors. You were changing the dx and dy values, the velocity modifiers. These little modifiers dictate exactly how many mathematical units an object travels across the horizontal x-axis and the vertical y-axis during every single frame. You were playing with pure geometry without writing a single math equation. How cool is that? And the third concept, which honestly might be the most magical, is the animation frame loop. You see, smooth movement on a computer screen isn't real. It's not a video. It's a continuous illusion. The browser is rapidly clearing out that entire canvas and redrawing every single position roughly 60 times a second using a function called request animation frame. That function is the literal heartbeat of every single web animation you will ever build. And you were just the director calling the shots. See? You didn't have to spend weeks studying geometry or syntax just to understand how a digital canvas operates. You found a value, you changed it, and you watched the feedback loop happen in real time. You broke it to understand it. So I want to leave you with this final provocative thought. If a totally simple text file, generated in seconds by an AI, can render 60 custom visual illusions a second right on your desktop, what are you going to command your AI to build next? The sandbox is wide open. Go twist some knobs. Thanks so much for joining me on this explainer.